Okay, so what we're going to be doing is we're going to be doing something pretty cool. So now that we've kind of started doing the projectile motion unit, I'm going to do a pretty fun experiment and show you guys kind of a real life scenario that involves breaking stuff and then how we use that to solve the problem of how fast it was actually going, when it left, and when it actually fell and hit the ground, giving us kind of the reason why it probably broke when it hit the ground. Okay, ready? I'm ready. Let's go. Okay, so there's three things that I have to measure. The first is the distance from the glass to the ground, which is going to be our y distance. And then I need to measure the distance the glass traveled horizontally, or that's going to give us our x value. And I also need to know the time it took for the glass to hit the ground. So what those values turn out to be, x is 1.04 meters, the time it took was 2 seconds, and the distance that it traveled to hit the ground, or the y distance, was 1 meter, which we're going to consider as negative 1 meters, since it traveled downward. Okay, so how are we going to do this? So our first step after we took all of our measurements is we're going to draw a picture. So my lovely artistic abilities here of the glass and it breaking. What you want to notice though is all of the labels that I put on my picture to tell myself which direction and what connotation that I have to give each one of these values. Okay, so now that we have our picture down, our next step is going to be to draw our givens and finds in our XY components. So notice that each one of my givens, I have an X and a Y component for each of them, and my finds are the same way. Finds are a little bit tricky, but you want to make sure you label each section to make sure you're finding the right things. It's much more important that you label your givens in the X and Y coordinates. This one, I like to keep mine color-coded, but you don't really have to. Okay, so step number 3 to solve my problem. I have to do the math. So I have to find the right equations to finish the problem. So my first equation here is going to tell me what my initial x velocity is. So what I'm going to do is I'm going to plug my x value in here and my t value and solve for the initial x value. And this is what I get. And then I wanted to know what my final x velocity is, and x velocity is going to kind of be equal to the same final x velocity, since our x velocity vector never changes. Okay, so now comes the more important and more fun part. So I want to figure out how fast it was going once it hit the ground. So I know how fast it started out going. So now how fast did it go when it hit the ground? Notice that my velocity is negative, and that's okay. That may seem a little weird, but that's okay. What that means is that it was going downward on its path as opposed to kind of going upward, as our kind of initial velocity would have been if our projectile was launched up instead of just horizontally and down. Okay, so now how cool is this? Well, let's see. Okay, so our initial x velocity was only about 0.52 meters per second. So that doesn't seem like a lot. We don't always deal with meters per second in our country yet. We haven't gone to the metric system yet. So it's about 1.16 miles per hour. It's pretty slow. So that's how fast it started out. And then, by the time it hit the ground, it ended up going 19.6 meters per second, which equals 43.84 meters per second, or miles per hour. So that's pretty fast. That's about how fast we would supposedly go on a 45 mile per hour road. Pretty fast. So that kind of explains to us too why when the glass hit the ground it probably shattered, because it was going really fast, even though it was only falling from a meter, which was from the back of a bed of a pickup truck. Who knew? Pretty cool? Pretty cool. Okay, so we're going to do some more problems once we're in class together, more of these horizontal motion problems, and we're going to use some of these steps in order to solve those problems. It may not be as cool as this breaking glass problem, but it still will be pretty cool, I promise. Hope to see you soon.